Hi folks, this is a quick revision lesson on the beginning of pressure. So we're just going to look at solids exerting pressures on solids. So the first thing you need to know is that when a force acts over an area, we say that there is a pressure acting normally against the surface. So what does this word normally means? Well, if I've got a force, say for instance the force is, even if the force isn't acting perfectly against it, say for instance it's acting at an angle, we would say the pressure is acting normally against the surface. And pressure is a vector, so that means that the direction is important. Pressure is defined as the force divided by the area. If you measure the force in newtons and you measure the area in meters squared, well then of course the unit of pressure is going to be the newton per meter squared. Now this unit of pressure is called the Pascal. 1 Pascal, abbreviated like this, is 1 newton acting over 1 meter squared. So it's important to have an idea of what a Pascal is. So for this, what we're going to do is we have to imagine what a newton is, and we're going to imagine it as a weight. So you know that the equation for weight is the mass times the gravity. On Earth, gravity is 10 meters per second squared. So 100 grams has got a mass of 0.1 kilograms. So it's got a weight of 0.1 times 10. It's got a weight of 1 newton. So if you've got 100 grams of sugar, say, on Earth, that's got a weight of 1 newton. Now, if you evenly spread that sugar over 1 meter squared, so down here, say for instance, I've got a meter, a meter, a meter, and a meter. If I evenly spread that sugar out over that area, well then I would say the pressure acting underneath that area is 1 Pascal, or 1 newton per centimeter, per 1 newton per meter squared. Now, you can also you could decide to measure the force in newtons, but you could also decide to measure the area in centimeters squared. A common mistake is people think that 1 newton per meter squared is equal to 100 newtons per centimeter squared. Absolutely wrong, totally wrong. So to show you how this works, let's consider a square meter. So obviously if it's a square meter, it's 100 centimeters by 100 centimeters, and that means the area of that is going to be 10,000 centimeters squared, because it's going to be 100 centimeters multiplied by 100 centimeters. Now, that means 1 meter squared is equal to 10,000 centimeters squared. So 1 newton per meter squared is really equal to 1 newton over the exact same area in centimeters squared, and that's 10,000 centimeters squared. So you have to use this to do questions like this, to convert 300 pascals to newtons per centimetre squared. You know that a pascal is a newton per metre squared. So what you have to know is you have to say, right, I know 1 pascal is equal to 1/10,000 of a newton acting over a centimetre squared. So what that means is if you've got 1 newton acting over a metre squared, so 100 grams of sugar over a metre squared, that's the exact same as 1/10,000 of a newton, or 1/10,000 of 100 grams of sugar acting over a centimetre squared. So now, because you know this relationship, you can just multiply both sides by 300. So this side by 300 is going to give you 300 pascals, and that's equal to the other side multiplied by 300. So 300 multiplied by 1 over 10,000. And then you cancel these zeros, and you're going to get, well, that's going to be equal to 0.03 newtons per centimetre squared. Of course, you can get asked to go the other way. You can be given a number in newtons per centimetre squared and asked to convert it back to pascals. Again, if you remember this, 1 pascal equals 1 over 10,000 newtons per centimetre squared. Well, then you know that 10,000 pascals is equal to 1 newton per centimetre squared. So if you've got 10,000 newtons acting over a metre squared, that's the exact same pressure as 1 newton acting over a centimetre squared. So what is the pressure going to be? Well, the pressure then is going to be, you've got 300 newtons per centimetre squared is just equal to 300 multiplied by 10,000 pascals. So it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 pascals. And how I arrived at that answer is I use this relationship here. I knew what 1 Newton per centimetre squared was, so I multiplied this side by 300, that can be 300 newtons per centimetre squared, therefore I had to multiply this side by 300, and that's how I arrived at my answer. Okay, the typical question that you get asked in this is you have to figure out what is the maximum and minimum pressure that can be exerted on the floor. Okay, so what we've got is we've got a mass of 2 kilograms. Well, the weight isn't going to change the same, so if this is on Earth, and we would assume it is, that the weight is going to be equal to the mass times the gravity, and that's just equal to the mass, which is 2, multiplied by the gravity, which is 10, so that's got a weight down of 20 newtons. Now, if I want it to be the maximum pressure, I'll put it on the minimum area. So the maximum pressure is going to be when it acts over an area of 3 centimetres by 2 centimetres, which is 6 centimetres squared. And the minimum pressure is when it's over the maximum area. So the maximum area is going to be this one here. So that's going to be 5 centimetres multiplied by, that side is 3. So that's over 15 centimetres squared. So, just over the page, the weight is 20 newtons and the max pressure equals 20 divided by 6 newtons per centimetre squared, and the minimum is going to be 20 newtons because that's not going to change, over 15 centimetres squared. And if you just cancel down the numbers and keep the units, that is the correct answer. Okay, that is all that you need to know on pressure for solids pushing against solids.